Okay, hi everybody. So today I was playing around a little bit with Terraform modules and Terraform module registry. So I thought, okay, let's see how I could not find a lot many videos in YouTube or blog posts explaining how to upload modules into a Terraform module registry. So I thought to create some sort of a concise video on this topic. Okay, so people who have been working with Terraform for more than 2 to 3 months, they know about Terraform modules, right? So basically Terraform modules kind of like, for example, you can have a different type of modules, say for example, one module for a VPC, one module for a VNet, and basically a module is kind of like a singular unit of action. You call that module and then you create infrastructure. Okay, so as you can see, it is basically a set of Terraform configuration files in a single directory. Okay, so when you run Terraform command, directory from say it is considered as the root module. So you have initially you are in the root module and then you can call sub modules. So what normally is contained in a module, it contains some inputs, it contains some outputs, it contains some variables and a main.tf file, which is basically the code logic of the module. So for example, if I want to show you a module, one second. Okay, so this will be one module. So for example, this module takes, for example, as inputs this kind of values. These are the inputs to this module. Okay, so basically this module will create a virtual network. So these are the inputs. You need the CIDR of the virtual network. You need how many private subnets, how many public subnets, and all of that. Okay, then you will have a main.tf. So this is basically the code of the module. This is where you are actually calling the resource provider. In this case, I am using the Microsoft Azure RM resource provider, and I'm actually creating the resources. So this is the core of the module, right? And so when a module will run, basically you will call the module just like you will call any function in object-oriented programming. We call functions in functional programming. Basically, similarly, we call a module with some inputs. Okay, so when we call them, so basically we need to provide these inputs to the module. The module will be called. All of these resources that are defined in this module, they will be created. Okay, and finally we'll get some outputs. Okay, so typically you will see that what happens in companies is that, for example, that many people write the same module. So say for example, I wrote a module for virtual network in my way, and then you say in another team also wrote the virtual network because you are not aware of my module. Everybody is creating modules, so this leads to module sprawl. So say for example, the same virtual network module, there might be 15, 20, 30 virtual network modules in the same team or in a big organization or an enterprise. So this is where HashiCorp came up with an idea of a module registry. Okay, this is just like, for example, in container registry, for example, like in Docker Hub or Hardbird or Azure Container Registry, you keep container images. Similarly, in Terraform registry, you can keep Terraform modules, and then what you can do, you can directly search for your modules there. You can upload modules and stuff like that. So basically, at least I think you are now aware of what a module is. Okay, but you need to do more deep dive, so I will share you this link. So there's a very, so anybody who has been working long time with Terraform, they should know this, and because this is kind of like the bedrock of Terraform. Now coming to what is a module registry. Okay, so for example, if I go here, so one second. Okay, so this is a Terraform registry. So I have already logged in, otherwise it will ask you to log in with your GitHub credentials. Okay, so this is, so you can see, you can also search for resource providers like, for example, AWS, Azure, VMware, whatever, console, Vault. Similarly, you can search for modules. So here I am interested in modules, so I am clicking on browse modules. So for example, say I am searching, for example, VPC. So see, I can see all of the VPC modules here. So this is a VPC module. So this is a AWS official VPC module. Okay, sorry, this is the provider. Let me go to the module. One second. Yeah, okay, I got the module. Okay, so this is a Terraform AWS VPC official module. So what we can do, say for example, I want to create a VPC. Okay, then rather than writing the entire code for the entire VPC setup, I can simply call this module. So this is my module, this is the source. Okay, this is a version of the module, and then I will call with what are the inputs. These are all the inputs. So there are total of 160 inputs, but not everything is required. There are many optional inputs. So for example, the required inputs you can give. Okay, and then it will basically create the VPC for you. So this is the idea of the module. Now my question is that So the question that can come is, okay, this is a module that AWS company has created for a standard VPC, but I might use another type of a module which is a little bit catered to my use case. Okay, say I have created a module. So here, as you can see, I have created a module to create multiple virtual networks using an array. So for example, say I want to create, say for example, two virtual networks. Okay, I don't want to call, so I can do, for example, here this is something, an input I have given. So say for example, okay, so this is virtual network 1 and this is virtual network 2. Okay, so this is 10.0.0/16 and say for example this is 10.10.0.0/16. So I want to create something like this so that my module will take this as an input and create two virtual networks. And within those virtual networks, it will also create subnets and also will create, for example, private subnet, public subnet, set the DNS of the VNet and everything. It will basically, so these are tailored for my use case. Now I have created this module. Okay, but how will other people use this module? How will they go and use this module? So I need to publish this to my registry. Not my registry, is a public registry. So there are public Terraform registries, there are private Terraform registries. The private Terraform registries are paid registries. So you can buy Terraform Cloud or Terraform Enterprise and you will get a private Terraform registry. But here today we are focusing on public Terraform registry. So keep in mind that whatever is in this public Terraform registry, for example, this one, this free. So meaning this is open source. You can even see the source code here. Okay, so it's very important that whatever you publish in the public Terraform registry is free or open source. Okay, so you will be able to see the code, you will be able to report issues and everything. So you can see this is the VPC Terraform. This is created directly by Amazon Web Services as a company. Okay, now but what about my, how can I upload my? So if you see, there is a very nice article here that kind of explains the procedure. There are some nuances here and there, so I will explain them, but the idea is you have to follow some rules and then you are able to publish the registry. So here if you see, the module must be on GitHub and must be a public repo. Just like I said, it has to be on GitHub and it has to be a public repo. This is the only requirement for the public registry. If you are using a private registry, you might ignore this requirement. So if, for example, I have a private registry like Terraform Cloud or Terraform Enterprise, then I don't need to basically expose my code to the public. So I don't need to keep it in a public repo. So in my case, I have kept my code in a public repo. So this is my public repo. The very important thing is that the repo, there needs to be a one-to-one connection between one repo and its associated module. So for example, this repo will only contain virtual network module. That is why if there are two modules, then I need to create two repos. So for example, if you see here, I have two repos. One second. Yeah, see, this one repo is for virtual network, this repo is for virtual machine. I will not have both of them in the single repo. Okay, so you can see this repo is just for virtual network. Okay, similarly, if you see this one, this is the AWS. So here also, if you see, these are created by AWS. This repo is only for VPC. Now there can be sub modules within them. Okay, but essentially this is a one-to-one mapping between a VPC module and this GitHub repo. And the naming convention also of your GitHub repo you have to maintain. So for example, the next one, you have to name the repo with Terraform-provider-name. So if you see my repo, what I have done, so my name is Terraform-Azure because my provider is Azure. Then multiple virtual network. This is the name of my module basically. This is what will show. Now if you see how it is published, so this is published like this. So you can see this is so it's a Terraform registry module. So you can see the Azure because it's in Azure. I had mentioned here Azure. So it has got here Azure and this is the name multiple virtual network. So this is the name multiple virtual network. So these are one-to-one mapping. Okay, so now how did I manage? So what I have done here, I have basically created this repo as a public repo. Then I pushed all my code. I will explain the code later. I have pushed all my code here. So say for example, all my code is in the correct format. Then what I will do here, I will just come here, publish. I will select module. Okay. It will ask you to log in with your GitHub credentials. Very important that this only today supports GitHub. So this is also mentioned here in the logic. If you see, the module must be on GitHub only, so it only supports GitHub. Very good. Now if you see, it will only show my GitHub repositories which are kind of refactored with the name in this format. It will not show any other GitHub repository. So in this case I have two GitHub repositories which are in this naming format or naming convention. One is a multiple virtual machine, another is a multiple virtual network. Now I have published both of them, that is why it is coming is already published. But if I had not published them, then I could have published them from here. Very good. But there are many other conditions. So this is the idea. Now if you see the third condition, okay, this is okay. Repository description, this is very standard. What is repository description? Whatever you are basically describing in your repo. So if you see, this is my readme. This module will help us to create more than one Azure virtual networks. Okay, this is what I have mentioned in my repo as a sample. So if you see my Terraform module, one second, let me go there. Okay, so you will see the same, basically you will see the same here, the readme. This module will help us to create more than one Azure virtual networks. So you need to explain everything here. If you explain everything here, it will start coming here and people will understand. So if you see a good Terraform, this was created by Amazon Web Services. So you see there is a lot of input here. They've given all the inputs that you need for anybody who does not know the logic of your module to be able to use this. Okay, very good. Now what is the next requirement? You have to follow a standard module structure, because you have to follow standard structure with the same standard naming conventions, standard pattern, standard subfolder structure. Otherwise, how will Terraform registry be able to scan that? Terraform registry, you are just pointing, giving the link to the root of your GitHub repo. You are giving a link to the GitHub repo. It needs everything in a proper format so that it can read it and then populate your module registry. So what is the standard module structure? A standard module structure, if you see here, is basically kind of, so the normal standard module structure, it will contain a main file, it will contain some variables which are inputs, it will contain some outputs, and it will contain a readme. Also, it can contain some nested modules. If you need, for example, if this module is dependent on some other modules, it will contain nested modules. Also, it can contain some examples. So examples are basically Terraform files which show how to use this module. It gives kind of like a reference on how to use this module. So this link also I will share. So basically, so if you see my repo, you can see, if I close this one, okay, so if you see, I have a main file. Very good. I have a variables file. Okay, these are all my inputs. I have an outputs file. These are all my outputs. And this versions file, this is basically where I am storing what is the dependency of my module. What are the providers, or what is the Terraform version that I need for this module to run. So for example, this module runs with any Terraform version after 0.11. So if you have 0.11, 0.12, 1.0, whatever, it will run. Similarly, it needs, for example, the this needs to be Azure equal to, sorry, let me just change it here. Okay, no problem. So for example, the HashiCorp Azure provider with 1.22. Anything more than 1.22, this code will run. Similarly, I am also using a null resource provider. Anything more than 0.1 version, it will run, no issues. So this is a versions file, and this is the examples file. So in the examples file, what I will have some code on how to call this module. So for example, if I want to call this module, then these are the inputs I need to give. What could be the values of those inputs? So I have given some sample values. So all of this are here. So as soon as I publish all of them there, you will see that it will start coming here. Let me come here. Yeah, okay, perfect. So as soon as I publish here, it will come. So now once I will publish, you will see there is a version. There is a version here, one. So this is the next important thing. So after you create a module with a standard module structure, you can only upload the module as a registry if it is released. Meaning, what does it mean? So because the module registry will scan your GitHub repo, and basically it will look for release tags. So what does that mean? Say for example, I go to my GitHub repo. So this is my multiple virtual network. Say I want to make some changes and I want to create a new release. Okay, so what is the change I am doing? So let me first go and do some change. So what is the change? Say I am doing an edit here. Okay, and I'm saying this is part of live YouTube demo. Okay, very good. Let me comment this change. So I have made a change. Now what I want to do, I want to create a new release. So my earlier release was 1.0.0. Now I will create a new release which is 1.0.1. This is how, this is the tag with which Terraform public cloud registry, basically Terraform public module registry, will basically scan for these tags and get this. Okay, so you can see 1.0.1. Now if I come here, you will see if I refresh this, you will see 1.0.1. okay, and you can see this is part of YouTube demo. And if I go to version 1.0.0, this does not have that line, because this 1.0.0 is a direct mapping with the 1.0.0 release tag, and the 1.0.1, which is the latest one, is a mapping with my layer. So this is how you can keep on upgrading your modules without impacting your earlier versions. Okay, so your 1.0.0, some guys can point to your 1.0.0 module. Well, you can work on 1.0.1, 1.0.2, 1.0.3. So this is what is basically explained here. If you see x.y.z tags for releases, the registry will use tags to identify the module version. Release tag names must be a semantic version which can optionally be prefixed with a v. For example, v0.0.4 and 0.9.2. To publish a module initially, at least one release tag must be present. Without a release tag, you cannot publish the module. So these are basically the requirements for publishing all of these modules. Okay, so for example, if I can just show, okay, so let me just try to do one thing. Let me delete this module first. Perfect. Okay, I only have one module. Now let me try to publish a module. Let's see if it works. So for multiple virtual network. Okay, so this is how you will publish. Okay, so what I had done, I had actually first logged in to the Terraform registry, okay, using my GitHub account. So there is a link with GitHub. Once I did that, it will only show me, I have lot of repositories. If you see my repos, for example, there are 17 repositories. Okay, but only these two are coming because of the naming convention. It is very important to understand. Without this naming convention, it will never even show up here. So following the naming convention that I had explained, this naming convention, this Terraform provider name. So you can see module repositories must use this 3-part name format. It's a must. Okay, otherwise it will not happen. Then I will create multiple virtual network. Then I say I agree to the terms of use, and then I say publish module. So it's publishing my module. Okay, as soon as I publish, you can see version 1.0.1 is here. So now if somebody wants to use this module, they don't need to understand a lot. They will check my readme, they will check what are my inputs, what are my outputs. Okay, and finally they will basically call my module like this. So they will call my module, they will insert this is a version 1.01, and finally they will insert the values of the 13 required variables here. So what are the inputs? So app identifier, DNS map, entity, and what happens is that whatever description, okay, you give here, whatever here, the same description will show here. For example, let me show you. If you see this variable, default name to use with your, okay, sorry, not here, this one. Yes, default name to use with your resource names. This is the description of app identifier. Okay, so if you see here, you will find the same description, default name to use with your resources. So if you give good descriptions here, okay, then it will be very easy for somebody who is using your module to use it. Okay, similarly outputs, whatever we give there, the same thing will come. All of the outputs will come here. Here it will show what are the resources that this module is creating. It is creating a gateway subnet, a private subnet, a public subnet, this vnet, deny internet, whatever. Okay, then there you have inputs. Okay, a lot of inputs it is asking for. Okay, And okay, now regarding this example section, so basically you can also store examples. So example, this is an example I have stored here. So here you can also come and here you can see the example. So you can basically click here and you can even call the example module virtual network. This is the example. Okay, so this is just for using the topic. Okay, so basically the idea here is that you should use the Terraform module registry to first search for modules rather than recreating modules. You should try to use modules which are, for example, already created by maybe the provider company directly. Okay, for example, maybe it has been created by the provider company directly. Okay, so here you can see, for example, this is an Azure virtual network module which has been created directly by Azure. If I see here, this virtual network module, I can use source Azure VNet, Azure M. This is the latest version, and I have to insert two variables here. Okay, so you can see this is how it is asking me to insert. It is asking me to insert an address space, subnets, subnet names, subnet service endpoints. So basically, rather than trying to reinvent the wheel and basically create my own module to create virtual networks, I should rather try to first use these modules. Okay, because these modules are maintained already and these are completely free. I can put the version 2.5.0 or whatever version I want, and then it doesn't matter whether Azure updates this to other versions, it will still be same. Now if you see, for example, here, this is their repo for Azure virtual network. So here if you see this, one second, yeah, so this is the main.tf file. So you can see this is the main. It is creating the virtual network, it is creating the subnets, it is creating network security group associations for some subnets, route table associations and stuff like that. This is actually what it is doing. Now if I come here, okay, now, yeah, and see what are the resources it is creating. These are the resources it is creating for a subnet, a network group association, a subnet route table association, and obviously the virtual network. So I don't need to basically reinvent the wheel and again create another module for virtual network unless and until I need to. I can do that, and if I need to, I can again upload it, and then other people can also use it. But if, for example, you have something which is uh, private, for example, then you cannot use it. Then you will have to use a private module registry. But using module registry is a very nice thing to do. And if, for example, you see this blog by Michel Hashimoto, who is one of the founders of Terraform, they have this blog is also very nice blog with kind of like, for example, the goal of this. So as you can see, the module registry is a key challenge for module producers and module consumers. For module producers, the registry is a central place to publish, version, and share modules. For module consumers, the registry is a central place to discover, use, and collaborate on modules. The module registry makes it easier for partners and community members to share and collaborate on modules and also to update and version modules to continuously make improvements to infrastructure configurations. Expert users can share their knowledge and beginners can get up and running on Terraform fast. So this is basically the idea. So I will do some more. Next step for me is to kind of like see if I can get a version of Terraform, trial version of Terraform Enterprise, or for example Terraform Cloud, and see if I can check their private Terraform registry. Okay, which is a kind of like more protected, but obviously you have to pay for it. But this is good for say, for example, proof of concepts, or for example standard kind of modules that you guys are writing. For this topic is a good topic. Okay, thank you guys, take care, and have a nice day.